All right, so let's take a look at number 16. You can see that this one is a little different. We got a sine squared x, and then we have a cosine x. So what we're going to do is we're going to use a trig identity so that we can get this to have the same trig function. And the first identity that you're going to learn is the Pythagorean identity. Again, we're going to learn more about the identities in the next section, but for here we're just going to use what's called a Pythagorean identity, and that is sine squared x plus cosine squared x is equal to 1. So you might be saying, well, how is that going to help us? Well, if I take this here and isolate the sine squared x, I can do that by subtracting cosine squared x to both sides. And if I do that, I get sine squared x is equal to 1 minus cosine squared x. Well, that means that sine squared x is equal to this, which has a cosine in it. So if I replace sine squared x with 1 minus cosine squared x, now this entire equation here has just cosine in it. So let me go ahead and do that. I'm going to take what I have here. So I got 2. I'm going to replace it with sine squared x is 1 minus cosine squared x, and then bring everything else that I have. The cosine x plus 1 is equal to 0. So let's go ahead and simplify this and see what we get. So we're going to do distributive property here, and that's 2 minus 2 cosine squared x minus cosine x plus 1 is equal to 0. And then I can combine my like terms here. So I got a 2 and a 1. So that gives me negative 2 cosine squared x minus cosine x plus 3 is equal to 0. And now this looks like the quadratic that we were doing before. We can factor this, but we don't want to factor with a leading coefficient that is a negative. So I'm just going to go ahead and divide both sides by negative 1 just to change the signs. So I get 2 cosine squared x plus cosine x minus 3 is equal to 0. Now we can go ahead and do our substitution, and we can say that x is equal to cosine x. And again, you could factor right from here, but sometimes students like to see it written like a quadratic. So it's going to be 2x squared plus x minus 3 is equal to 0. Now when I go ahead and factor that, that's going to give me 2x plus 3 times x minus 1 is equal to 0. And if I put my trig function back in there, that gives me the 2 cosine x plus 3 times cosine x minus 1 is equal to 0. So I'm going to go ahead and solve those, set them both equal to 0 and solve them. Bring this up a little bit. So I have 2 cosine x plus 3 is equal to 0. Cosine x minus 1 is equal to 0. So this, I just add 1, and I get cosine x is equal to 1. And then here, subtract 3. So I get 2 cosine x is equal to negative 3 over 2. And then divide by 2, and I get cosine x is equal to negative 3 over 2. So now we need to figure out, well, when does that happen? Well, if you look over here, you have cosine x is equal to negative 3 over 2. Well, this is outside of the negative 1 to 1 range there, so that's not going to happen. So this is just not possible, so we can ignore that. And if you weren't sure if you did the cosine inverse of both sides, you would see that you would get an error. So it's not going to work. Then we got to figure out, well, when is cosine x equal to 1? So again, you can think to the unit circle. And when would you get a 1 for cosine? Well, it's going to happen, either 1 or 0 is going to happen on the axes. So this is 1 comma 0, this is 0 comma 1, this is negative 1 comma 0, and this is 0 comma negative 1. Well, the cosine value, cosine is x. Well, this is your x and your y. So at 0, you have cosine is equal to 1. So that happens at x is equal to 0. Now I know if you went all the way around, this would be 2 pi, and you say, well, it's the same thing. But if you go back, and I'll scroll this down a little bit, the interval that we had is from 0, including 0, up to 2 pi. So we're not including the 2 pi there. So the answer for this one is just x is equal to 0. All right, so we'll go ahead and take a look at number 17. All right, so here's number 17. You can see that it's similar to number 16 where we have two different trig functions. So we're going to go ahead and actually use the same identity, the Pythagorean identity. We're going to say that sine squared x plus cosine squared x is equal to 1. And I'm going to go ahead and replace the cosine squared x with something so I can get a sine x in the whole thing. So basically I'm going to move the sine squared x over here, and I'm going to isolate the cosine squared x. So cosine squared x is equal to 1 minus sine squared x. So now I'm going to replace this with my cosine squared x so that I have the same trig function in the equation. So that's going to give me 6 parentheses, because don't forget we're going to have to distribute 1 minus sine squared x when I replace the cosine squared x with that, then minus sine x minus 5 is equal to 0. So now I can go ahead and do my distributive property, and that's going to give me 6 minus 6 sine squared x. Then I still have the minus sine x minus 5 is equal to 0. Go ahead and combine my like terms. So I got a 6 and a minus 5. So I have minus 6 sine squared x minus sine x plus 1 is equal to 0. And just like we did in number 16, we don't want to factor with a leading coefficient that's negative. So I'm just going to divide both sides by -1. And that's going to give me 6 sine squared x plus sine x minus 1 is equal to 0. So now at this point, you could either factor right from here or do your substitution. And I'm going to say that x is equal to sine x. And then that would give me the quadratic 6x squared plus x minus 1 is equal to 0. So we can go ahead and factor from here. And that would give us 2x plus 1 times 3x minus 1 is equal to 0. And then of course we can substitute back in our sine function. So that would give us 2 sine x plus 1 times 3 sine x minus 1 is equal to 0. Move this up a little bit. So now I'm going to go ahead and set those equal to 0 and solve them. So if I do that, I have 2 sine x plus 1 is equal to 0. 3 sine x minus 1 is equal to 0. So here, subtract 1. So 2 sine x is equal to -1. Divide by 2. So sine x is equal to -1/2. And then over here, I'm going to add 1. So 3 sine x is equal to 1. And then divide by 3. And you get sine x is equal to 1/3. So now what we need to do is figure out when is sine x equal to -1/2 and when is sine x equal to 1/3. Well, if you look here, the -1/2, that should look familiar to you. That's going to come from the unit circle. But sine of x at 1/3 is not. We're going to have to basically do the inverse function and then work with our reference angles. And basically we're going to wind up with a rounded answer. And a clue to that, if you go back here, and you can see that I'm saying solve this in the interval from 0 to 360 degrees. So I'm not saying in terms of pi, which typically for me means that some of the answers are going to be rounded. So when we go back here, now I'm just going to go over to the right space here so I have some room. So for a sine of x equal to -1/2, you could either reference the unit circle or you can just do the inverse of both sides. And when you do that, you'll get, if you do sine inverse over here, so sine inverse, to both sides, so you get sine inverse of negative 1/2. That is going to give you negative 30 degrees. Well, negative 30 degrees basically means that your reference angle, your theta prime, would be 30 degrees because you have an acute angle. This is a negative acute angle. You just make it positive, and that's your reference angle. Well, also you know that sine is negative. You do all students take calculus. Sine is negative in quadrant 3 and in quadrant 4. So that means that this here is 30 degrees, and then from here to here is 30 degrees. So here to here, and then here to here. Well, in quadrant 3, so from this all the way to here is going to be our quadrant 3 angle. So our Q3 angle is going to be 180. So from here to here plus this 30. So that is 210 degrees. And then our Q4, if you go all the way around, is 360, and then subtract this little piece, that will give you from here to here, which is the angle that we want. So 360 degrees minus 30 is equal to 330 degrees. So those are the two answers from sine x is equal to negative 1/2. Well, let's look at the sine x is equal to 1/3. So again, if I do the inverse, I get x, should have put the x over here, sorry. So x is equal to sine inverse of 1/3. And when we do that, we get 19.47. Well, that means that our reference angle, so theta prime, is 19.47 degrees. Well, again, we got to figure out, well, where are we? So all students take calculus, and sine is positive. Sine is going to be positive in quadrant 1 and quadrant 2. Well, my theta prime is a positive acute angle, so that's already my quadrant 1 answer. So I already have that. So Q1 is 19.47 degrees, which is also the reference angle. And then that means for my quadrant 2 answer, which goes from here to here, remember this piece is going to be 19.47 degrees because it's your reference angle. So my Q2 angle is going to be 180. So from here to here minus the reference angle. So minus 19.47 degrees, and that is going to be 160.53 degrees. So our answers are all 4 of these. So basically x is equal to 19.47 degrees, 160.53 degrees, 210 degrees, sorry, 10, and 330 degrees. And that is our final answer. All right, so we'll go ahead and take a look at number 18 next.